says, for each of the following double displacement reactions, identify the products of the reaction in balance. For reactions that occur, identify the spectator ions. Please note that no reaction is a possible answer. Be sure to use the solubility rules. So in this case, what we need to do is we need to identify what could potentially happen and then see if we form something that's insoluble. If we don't form something that's insoluble in water, we just have a bunch of ions floating around in solution. We don't actually have a reaction occurring. So let's go ahead and see what's going on here. So here we have barium chloride reacting with sodium sulfate. If barium stays with chloride and sodium stays with sulfate, that's not interesting. That's not a chemical reaction. So barium has to either go with sodium or sulfate. Barium is positively charged. Specifically, it's 2+. Sulfate is minus charge and sodium is positive charge. So barium has no interest, that should be a 2 there, not an S. Barium has no interest in going with sodium because it's positively charged. It wants to go with sulfate. So barium goes with sulfate. Sodium goes with chloride. Now, before we bother to write the products of this reaction, what we're going to want to do is see if anything's insoluble. And here we're going to have to use the solubility rules. If you haven't watched the previous question, do that first because it goes over the solubility rules. So if we go with barium and sulfate, we have sulfates, which are generally soluble. But if we look, barium is an exception. And barium sulfate is actually the stuff they use in dyes, like if someone would drink it and then they'd give them a CT scan, something like that. It has barium, which is a large metal, so it absorbs X-rays, but it's not very soluble in water because generally speaking you don't want to drink heavy metals because they can be poisonous if they're soluble in water. So barium and sulfate is insoluble because sulfates are generally soluble because they're on the top of the list, but barium is an exception. So now we can go ahead and find the formula of barium sulfate. So we have Ba 2+ and SO4 2-. When they're both 2 and you cross them, you can cancel them out. So what we end up with is BaSO4 solid. Then we get NaCl. It's Na plus and Cl minus, but this one is common, so it's just NaCl. NaCl is soluble in water. If you're not sure, use your tools over here. You have 1A metals are always soluble. There's no exceptions. Chlorides are generally soluble, but sodium is not an exception. Plus, just from everyday life, we know that salt dissolves in water. So this one, because there's water around, is going to be aqueous. Now that we've found the compounds, what we want to do is we want to balance. So to do that, make sure that we use the polyatomic ion as a whole thing. So sulfates here and sulfates here. So we have 1 barium, 1 barium. 2 chlorides, only 1 chloride. So as a first best guess, I'm going to put a 2 there. 2 sodiums, 2 sodiums. 1 sulfate, 1 sulfate. So all we had to do to balance that was put a 2 in front of NaCl. Alright, in this case, we have copper 2 nitrate reacting with sodium carbonate. Same thing, I don't have the space to write it, but copper is going to go with carbonate. It's always the first one with the last one because positive and negative, and then positive and negative. Sodium is going to go with nitrate. So let's take a look. Copper and carbonate, let's look at our solubility rules. I'm going to find copper on here, but you can't find carbonate. Carbonate's on the bottom, so it's generally insoluble, and copper is no exception. So we can go ahead and find the formula. So we have Cu2+ and NO3-. Cross them like this, and you get CuNO3 2. This one is solid, because it's not soluble. Then we have sodium and nitrate. What am I doing? I'm sorry, I screwed that up. It should be copper, Cu2+, and carbonate, CO3 2-. Cross them. They're both 2, so they cancel out. And what we end up with is CuCO3 solid. Sorry about that. It's not copper nitrate. That's what it already was. So copper goes with carbonate. Sodium goes with nitrate. So we have Na+, NO3-. They're both 1, so when you cross them, you get NaNO3 aqueous, like so. Now we need to balance. We have 1 copper, 1 copper. 2 nitrates, only 1 nitrate. Do not try to balance oxygens because it'll get confusing. nitrate, nitrate. So if there's 2 nitrates, we need 2 sodium nitrates. 2 sodiums, 1 carbonate, 1 carbonate. All we had to do was put a 2 on sodium nitrate. I forgot that we are not finding the spectator ions. The spectator ions are your aqueous products. So your spectator, I'll write them over here, in this case are your aqueous products. So Na plus, Cl minus. Why are these spectator ions? Because they're simply floating around in solution over here. Remember this this dissociates into Ba2 plus and Cl minus. This dissociates into Na plus and SO4 2 minus. So they're just floating around as ions. They're still floating around as ions over here. Because this is aqueous, it dissociates into Na plus and Cl minus. So your aqueous products are your spectator ions. In this case, it's Na plus NO3 minus as your spectator ions. Let's look at the next one. We have MgCl2 and KC2H3O2, which is acetate. So let's take a look here. Magnesium goes with acetate. K goes with chloride. So let's look at acetates. Okay, you're not going to find magnesium on here. Acetates, which is CH3COO minus or C2H3O2, this is the same thing, are always soluble with no exceptions. So magnesium acetate is soluble and will be aqueous. Potassium chloride. So here we have K plus, which is always soluble, and chlorides, which are soluble, and potassium is no exception, which is soluble, which means that all your products are aqueous. Magnesium acetate would be aqueous, and potassium chloride would be aqueous. Said another way, you have a bunch of ions floating around in solution that don't actually react with each other. This is a mixture of ions. It is not a chemical reaction. So the best answer here is simply no reaction. Next one, we have silver nitrate with sodium sulfide. So what we want to look at is silver going with sulfide and sodium going with nitrate. So silver sulfide, we want to look up sulfides because we're not going to find silver over here. We look up sulfides and we see that it's at the bottom, so it's insoluble, and silver is no exception. So we have Ag plus S2 minus, cross them, and we get Ag2S, which is not soluble, so it's a solid, and that's the driving force of this reaction. Sodium goes with nitrate. We already found sodium nitrate before, but we have Na plus NO3 minus. We cross them. They're both 1. And we get NaNO3, which is aqueous. So here's our aqueous product. Now we need a balance. If we look, 1 silver, 2 silvers. So I want to put a 2 there. We have 2 nitrates. We only have 1 nitrate over here, so I want to put a 2 there. 2 sodiums. Now we have 2 sodiums, 1 sulfide, 1 sulfide. So putting a 2 there and a 2 there is balancing. To find the spectator ions, remember everything's an ion floating around in solution before it reacts. So you only care about what after the reaction, what's still floating around in solution. And that would be your Na plus is a spectator ion and your NO3 minus is a spectator ion.